So welcome back to Basic SU Training. Today we're going to move into Module 2, so EM methods and operation. So designating. As we talked about, designating is the process of using a transmitter to induce or propagate a signal across an inductive facility and receiving it with the receiver and designating the horizontal pathway of that facility. So how do you do that? So you use the receiver system, and the receiver, once the transmitter is hooked up properly, the receiver will let you know a number of things. As you're getting near the facility, the receiver will start making some noises. Generally, it's a series of tones or beeps that will let you know that it has acquired the signal and that it is in the general vicinity or the zone of where that signal is. And now, in order to refine that signal acquisition, you move the transmitter laterally across the surface of the ground, just an inch or so above the ground, side to side, not in a swinging motion, in a level lateral motion until you identify where the peak signal is. And the receiver will tell you that. It has a series of numbers and perhaps some arrows on it that will indicate to you that you have identified the signal, and then by paying attention to those numbers and arrows, you can identify where the peak of that signal is. And where that peak is, unless there's some interference, where that peak is where the center or the proper pathway of that signal is located. And then if you want to make some confirmations on that, what you would do is you would take the receiver and you would rotate it 90 degrees to that facility, and what would happen, or what should happen, is, provided there's no other interference, the noises will stop and the signal will go to virtually zero, and that would tell you that you have identified the correct signal, you've identified the pathway of an underground facility, and that your signal is secure and correct because you were able to null it out. So one of the other things that we have to do is, oftentimes we don't necessarily know where the facility is running at. So we may have identified a connection point where we can hook up to the facility and begin imposing a signal on the facility, but now we have to search for where that facility is. So we search in a grid pattern, and it's very methodical, and this graphic indicates the best way to search in that grid pattern to identify where that facility is and to start being able to pick up that facility and then being able to trace it. So some very important things about signals. And as we talked about briefly in Module 1, there is the propensity for these electromagnetic signals to bleed off on other facilities. If there are other conductive facilities within the vicinity of your target facility, it is highly likely that some of your signal will bleed off onto the other facilities. But there's a way to diagnose that you're actually on your correct or your target facility, the facility that you're hooked up to. So as you're sweeping your device across the surface of the ground, in this particular instance, like the graphic represents, there's 3 facilities. And what will happen is that the shallower facility will have a much higher signal number. In other words, so quantity of signal, much higher signal quantity. And like it indicates here, the conventional locator response would say 100%. And most people would say, okay, that's my strongest signal, so that must be my target line. And unfortunately, that's not correct. So the way that the electromagnetic theory works is that those facilities that are nearer to the surface will represent a higher quantity of signal, but not a higher quality of signal. And so as you can see from the graphic, if you were to move over, you would notice that you had 60% on your target facility and 40% on this other, non-target facility. But you have to pay attention to the amount of current that's being carried by these facilities. And you will notice that your target facility is carrying the highest amount of current. That is always going to be the facility that you are hooked up to, whether it's inductively or conductively, whether by clamp or dropping the box. The facility that you have targeted, that you have hooked up to, is the facility that is going to carry the highest amount of current. That is your target facility, not the highest quantity of signal, it's the highest amount of current. In this case, 27 milliamp current would indicate to you that your target line is here and that you have to ignore that other shallow facility that has a higher quantity of signal, a signal count number, because it is not your target facility. So, dropping the box. So when you know that there's a facility there, but for whatever reason you can't get to the access point, you can't connect to it, you can't access the riser or the tracer or the pedestal, whatever it happens to be, or it's just not near enough to where you need to do this locate, you can use this method to drop the box. It can be very accurate. Again, you have to pay attention to a number of ideas. Still the basic tenets of EM theory apply. Follow your peak null and your current strength and your current direction and null out your facility. And if you follow the proper procedures, using the drop the box method can produce a very accurate result. Current direction is another issue that can help you diagnose your signal. So as I talked about early on, the current flows from your transmitter, always flows from your transmitter away from you, okay? So in this graphic, you'll notice here the darker line, okay? You'll notice that that dark line indicates, okay, here's our transmitter, and our transmitter is transmitting this signal, and it's where the way the arrows indicate, that signal is flowing to this other location where it finds a ground, and then again it flows back through what we call ground path return back to its original source. So by diagnosing the current direction, you'll be able to tell also that you're on your target facility, because again, the current always flows away from the transmitter itself. And if it bleeds over onto another facility, that current direction will change. It will be opposite of the flow that you're supposed to be tracing. So all of our instruments have the current direction mode on there, which allows us to see that we are tracing the current in the proper direction, again, away from the transmitter location. And then if we were to start suddenly bleeding off on one of these other facilities that were adjacent to it, by checking the current direction indicator, we would know that we have suddenly not, we're not on top of our target facility, that the current has changed direction, and that is an immediate indicator that we have bled off onto something else. This is the same scenario, whether you're direct connected, whether you're clamp connected, or whether you've dropped the box. The signal is always moving away from the transmitter. So in this particular graphic, we show that we have inductively clamped on a particular conduit, and that we can see that the current is flowing away from that clamp. And so our current direction would show us that. And then if we suddenly moved over to one of these other three facilities, it would show that the current direction is headed back in the opposite direction, and therefore those are not our target lines. Very similar when you're doing a designation near things like a guardrail or other electrically conductive facilities that are nearby to your target facility. Again, wherever your transmitter is, that signal propagating from there is moving away from the transmitter. And in all other cases, doesn't matter if there's 1 or 50 other cases, those signals will change direction and try and go back to the transmitter. So you'll always be able to deduce whether or not you're on your target facility or not by making a determination as to what the current direction is. So some other pointers that we have is, again, the graphic at the top is very indicative of this. Wherever you connect your transmitter to, whether it's through a clamp or dropping the box or direct connection to the pipe, that signal flows away from that clamp. So here, as indicated, it is flowing away in both directions from the clamp. So you have to pay attention as to where you are relative to where your transmitter is. So if you were off, say, 100 feet to the right of this graphic, and you were looking at your current direction, you would notice then that your current is headed towards you if you were facing back towards the clamp. Okay? Now, if you had moved past the clamp and were 100 feet to the left of this graphic and you kept facing towards the left and moving away, then you would notice that the current direction is moving in the same direction that you are, moving away from the clamp. If you turned around 180 degrees and started heading back, your current direction would indicate that that signal is heading straight into you. You move down to the next graphic. We can force the signal to move in a direction by using an alternate grounding mechanism. So in this case, if we wanted to force the transmitter to push all of the available signal, in this case to the right, we would put our clamp and then we would add a ground wire directly behind the clamp in the direction that we don't want the signal to go, and we would ground that out. And then what would happen is all of the signal would then be forced to move to the right down line so that we could essentially push more, a higher volume of signal that way. The same on the bottom graphic. If we needed all the signal to go to the left, we would ground again behind the direct connection or the clamp, and force all that signal off to the left. This can be very helpful when you're trying to work on signals, or you need the signal to go farther than it normally would. You can cause it to be forced in a certain direction. That helps you diagnose some other issues with regard to current direction. One of the other methods that we utilize a lot is called a two-man sweep. And so, this method is basically used by having the transmitter held by one person, the receiver held by another. They're separated by 20 or 30 feet or more, preferably. And then they move in tandem, parallel with one another, across a given area, and wherever there's a signal hit, it's because the transmitter induced a signal on a line and the receiver found it. So this is particularly useful for unknown sites where we go out and just start doing an investigation. We can two-man sweep an area to confirm that we've gotten everything and to indicate whether or not we have some previously unknown facilities within the area. One of the other methods that's capable of our systems are capable of is we call passive electric. So our system can be set to 60 kilohertz, or pardon me, 60 hertz or power mode. or a harmonic of any of that. So a harmonic of 60, so 120, 180, 240, 300, 360, and so on. And what happens is, if there is existing overhead electric, the electromagnetic signal coming from the overhead electric system is broadcast outward from those wires, and sometimes for substantial distances, and that signal is re-radiated or repropagated on all the conductive facilities that are in the ground near those electric lines. And you can tell, again, it follows the same principle. So wherever the power generation station is, or the substation or whatever, from that generation station or substation or whatever, the power on that system is traveling away. It's being pushed out away from that generation or substation area. And so you can diagnose current direction again by that. And then what will happen is that signal will then be picked up, re-radiated by conductive facilities in the ground, and that, again, based on AC theory, that signal will propagate in the opposite direction that it is flowing on the lines that are in the air. This is a very useful method, because a lot of times we can go out and do some what we call passive sweeps with no transmitter, just the receiver in hand. And by using the re-radiated electric signals, we can locate, pardon me, I hate to use the locate term, we can designate the horizontal pathway of facilities that are in the ground that are capable of carrying or re-radiating electromagnetic signals. This method is not always reliable, but it is a method that we can utilize, and if utilized properly, can yield good results. Still, another method that we can use is what we call radio mode. And radio mode essentially is something very similar. It's the passive re-radiation of AM radio signals. And not just AM radio signals. It's a number of frequencies. It's satellites, it's cell phones, cell towers, radio towers, AM radio beacons, all kinds of stuff that propagates radio waves in the air, obviously they can't be seen, but conductive facilities in the ground can pick up and re-radiate those signals, and they can be traced with one of our pieces of equipment. Again, not always reliable, but it is a method to help us identify facilities in the ground. So whether you're using the power mode or the CPS mode or any one of the passive modes, you can go out and perform this kind of grid search to identify if there's any facilities in the ground that are re-radiating these signals, and then use that information to make a determination about coming back and reevaluating by dropping the box or by digging it up and exposing it. One of our other methods is what we call the circular sweep or circle sweep, using one of the active modes. Typically what happens is the two-man operation. So one person holds the transmitter, one person holds the receiver. So generally speaking, like in this graphic, the receiver person stands in the center of a circle or a radius area, and the person holding the transmitter moves in a large circle around the transmitter, the receiver holding person. They face each other so that the systems are aligned, and if there's a signal hit, the transmitter will connect to it, if you will cup the electromagnetic signal will couple to that facility, and the receiver will hear it. Likewise, we invert this, and we do that same process with the person holding the transmitter in the centroid of the circle, and the person holding the receiver walking the large circle around. Either way accomplishes the same basic idea. Depth readings. So depth readings are very important for a couple of reasons. One is it helps us diagnose whether or not we have a round signal or we have a distorted signal. The interesting thing is that these signals can be, not always, but they can be very accurate. Generally speaking, they're plus or minus 5% of the overall depth plus 2 inches. So if you're 10 feet deep, essentially the accuracy of that facility is plus or minus about 5 inches plus 2 inches. So you're plus or minus 7 inches. That's pretty accurate. Excuse me. So the idea is that the way that the system calculates depth is that there are 2 antennas in the system. So antenna top, antenna bottom. And as the signal that is propagated is received by both antennas, there's a calculation made about the time that it takes between when the antenna at the bottom received the signal and when the antenna at the top received the signal. And that time differential calculates to a depth. And so we utilize this depth again to help us not only figure out whether or not we're on the correct target facility, or whether or not we have a round or correct signal. Separately, we can also use the receiver to compare some information to verify whether or not our depths are accurate, and again, whether or not we have a properly round signal. So we use what we call the 70% rule. So from the center peak signal with our transmitter gain, or pardon me, our receiver gain set at 100%, we note the number. So let's just say that the number is 1,000, and while we're at the peak signal, we're getting a signal value of 1,000. And so we move laterally to the left or to the right, but in one direction. So we move to the left, and we move until that signal is 70% of the 100% value. So if the 100% value was 1,000, we move laterally until that signal is 700, and we put a mark on the ground. We move back towards the center of that signal, back to our 1,000 number, and then move laterally in the opposite direction until we get to 700. And we put another mark on the ground. And that distance between the 2 marks that we placed on the ground should be equal to the distance that your receiver tells you the depth is from the surface to the facility. Utilizing the drop the box method, we have to be careful when we take depth readings, because if we're within this 30 paces area near the box, our signal values will be incredibly distorted and we will get crazy depth readings. So we have to make sure that we're far enough away from the box in order to make sure that we are getting reliable, not we'll call quasi-accurate signals and depth readings. Anyway, that's the end of Module 2. So for more information, stay tuned for Module 3.